Okay, so everyone can hear me. If you can't, you better start shouting soon because I can't see the chat screen anymore. So starting off with our giant set female, very keen on this hashtag. It's something we discussed a long time ago, and yeah, I like it. And I like to do it in the area of the user group or the meeting, or Bletchley Park seems to be the obvious place to point to this. And although this is about Joanna Chorley, and I like the comment, like you know, in 1944 she'd fallen in love with the world's first electronic computer, but it's actually the 75% of women that worked in Bletchley Park, and then a lot of them sort of spewed out and went into, actually a lot of them went into the world of entertainment, sort of BBC and that, but quite a lot of them went into sort of starting businesses and like. So yeah, it's a very good article here, History Extra. Have a look. Yeah, so why would it be important to have a template? And for us, we do lots of different projects in lots of different areas. In fact, we don't do very many test projects anymore. But it's having a general template gives you, these are the 4 things I could think of at the time. So straight away, you're not looking at an empty plate. Well, it's an empty project really, and having to create it from scratch. So that's a big benefit for productivity. Most projects, I would say, certainly what we've found now, have common functionality. And I'll go through that in a minute. But the common foundation encourages similar working. So we're at 2 at the moment, but we were 2 and 2 contractors a couple of years ago. And having that common foundation on projects is very important because it encourages you all to all work in a similar way, but in a nice way, not in a beating each other up about the wrong thing sort of way. It's you know, here's the tool you should be using, which is much nicer. And very important for us is it enables non-disposable quick prototyping. So I can churn out, with this template, I can churn out a functional piece of code very, very quickly. And you know, in a day and a half, I can give a customer a button functioning prototype that they can press buttons on, and you can actually get real requirements. And then you don't throw that away. You can actually use that because you've got the template as a background as the good software that goes in straight away for that. So for us, very, very simple. There's not very many VIs in our template. Most of them are reasonably repetitive. So the parts are just a state machine. And again, if you've watched my DevCon presentation, that talks about that state machine. We have a QMH, a queued message handler for the UI. We try to queue as much of the UI stuff up, which is the way Windows works. But what it does is that decouples the user interface from the rest of your code, which is very nice. Configuration, which we use SQLite. So I'll probably very briefly brush over that, but I don't want to step all over Tom's presentation. And error handling. And again, we treat error handling quite differently, I think, than you're encouraged to in the LabVIEW world, because I'm actually more interested in the place where the error occurred than the actual sort of VI that the error occurred in. So it's very much more structured, I think, and it works much better for us for debugging. Hey, demo time. This is all going to be demo now. I don't think I have any other slides. So I'll just run through the different bits of the code, really. So you start off with a reasonably small screen, just because I find small screens are easy to make bigger than big screens are easy to make smaller. So I think if I just go through the various structures of it, so I'll probably then display, if I can, how this scales, because that's quite a common question I get. Oh, you're using standard LabVIEW, how does it scale? So I've got some very big applications which I can sort of show you. But essentially, all of our stuff, we try to have common iconography. We try to keep the numerics. So these are just coding standards, really. Having structures with numbers on is quite useful for phone support, I find. The blues are kind of telling you what you need to update to modify. And I've also fairly new, because I found that there were issues, is that it was good to put some encouragement of best practice. Now, for event loops, I think best practice is to get out of there as quick as possible. You don't want it hanging around in the event loop. Ditto the user interface queued message handler. Get out of there as quick as possible. Show me doing this and that. State machine, do everything in here. We tend to use state machines extensively. I like the way they fit in my brain. And error handling, it just sits there as another queue. So you see there's 3 main queues here. There's a transition queue to come out of the state machine, which I talked about extensively at DevCon. If you're interested, go and look at the videos, or I'll talk about it in a minute if you want. Error is just another handle errors, and I'll talk about that in a minute. And then the display queue is just another queue. And if I look in there, each one of those is structured the same. I don't like seeing references on the code. So all these references are wrapped. You can see this is just doing queue stuff. So all I've done is taken the queue prims and wrapped them up. So you can see here I try to minimize what references are around. To my mind, they clag up the block diagram with information you don't care about. So again, I'll do it. Actually, it's a working demo. So let's have a look at error handling first, because that's kind of vaguely interesting. So if I run this, that is our SQLite file. Now, our SQLite file handles all configuration and error logging. And if I press generate error, so these are just fake errors, essentially. So if I generate, right, there we go. You have to have an error come up, so you can view the error in a minute. So stick you. So I fired three errors off. Actually, I fired 4 errors off. I just give you the time of the error. But you can also have a look at the error history. So these are stored away in our SQLite database, which I'll show you now. I'll show you now. So I use Navicat to look at SQLite, which is cool. It's a cool tool. There's our error log. And all I'm doing is taking the error number and its source and just totting out the number of errors and the most recent error. I always think it's a source of extra memory leaks if you actually log every error into a file. It just keeps increasing. So what you actually need to know is, it's me, 999 is throwing up 50 million errors. It's doing it all the time. So that's all the information I kind of need. And it can be doing this in the background all the time as well, which is nice. So you can clear the alarm, and go back to where you came from, and that one actually clears, looks at the error log. So this is actually pulling it from the database. So this is immediate, and this is forever. So until you clear it, and I'll clear it. It's all gone. So all that functionality is in there. I'll show you that in a sec. Actually, no, let's show you it now. Let's do configuration next, because they're failure related. I can get both of them out of the way quite quick. Boop. So again, configuration, SQLite. You get the user interface. It's a bit of a clunky user interface, but it's all right. And the good thing about using a database for your configuration is you can have versions. It's nice, because it means you can do quite funky stuff like have different hardware setups, for example. Just load versions in. So you select your version, lock it, that's always going to be the version that's used. Save it. The other usability aspect of this is, let's kill this code. You can actually then go. So if you want a new parameter, just open the strict type def and add a new parameter. So I'll go into here, I'll go save as because I'm adding a new one. It should give me a new version. There's a new version put in. I lock that, press OK. Database. No. Somewhere is. Oh, there is there. Version 6. UKTAG. So, and that gives you kind of. It's like a config ini farm. But I find SQLite to be very much more robust and more transportable and stuff like that. So that's configuration. So again, that allows us to just chuck up new bits of configuration on the fly, which is, you know, if you've got constants in your code, it's quite a good idea to make them configurable. So let's just have a look at how we talk to the database. So we've got an overall wrapper, which is all the things I want to do for configuration. It's not something together. But dig into him. This is essentially our database stuff. So again, this is fairly high level. The abstraction is more to do with the template than it is to do with databases. Get a little bit more databasey. So we dig down a little bit deeper. I quite like doing these kind of things. SQLite is good. There's good documentation for it. And here's actual. Now we're talking SQL. So here we're doing SQL inserting. And this is using now the final layer before we get into actually driver code. This is using James Powell's tool, SQLite tool, which is fantastic. And you can see here it's actually binding it to the text, so it's doing binds rather than SQL. That's just because it's a blob, because it could be big, and it's also got error details which could have lots of characters that you don't want, or if it's a SQL statement that causes the error, you don't really want to embed SQL statements in text, so that kind of thing. But other things don't use that. I try to always go for the most simple way of doing stuff, so select all. You know, it's all reasonably standard. Okay. So that's configuration. That's error handling. I've done the two most complex things first, actually, so that's cool. So why would you queue up all the user interface stuff? Let's talk user interface stuff. So what's the point of that? So here is, again, I like enumerator types, so you'll see lots of that. So here I'm setting my display, for example, to idling or running. So you set running, all I'm doing is making the button visible. That's the only thing it's doing currently. But that could be a generic thing. You could be flipping a tab, which is a common thing we do, you know, to a running screen. But if we play this here, I press start, stop. What we're doing, you should see me. So say I wanted to add something new then, functionally. What would that be? I don't know. Let's have a like noise system. Okay, so we got a new indicator, which is slide. So what we want to do is update that. So I would go simplest form. I don't like this because auto cocks up in a normal way. My muscle memory works. Apologise. So let's go set slider. Okay. And as we're going to set him to a number, let's just go and copy something that's already got there. Okay. So if anyone's interested in this, then I'm more than happy to send them a copy and let them to play with it. I'm not going to set it on the tools now, but I think there's already too many play frameworks on the tools around. So, but if anyone wants to use it and thinks it'll be useful, a couple of competitors have, and they find it quite useful. So I'm quite happy to do that. But anyway, so here we got a new message all made up, and it's set slider. So the beauty of doing it this way is you can I find this quite valuable when testing displays and just so this could be in any old sub-VI, anywhere in your hierarchy. But now you can just test that your display works. That's as easy as that. It's cool. The other nice thing about the Q template is you can add to the bottom of the top, so your stops get added to the top. So you just say, right, I'm out of here. Okay, state machines. So you can see I'm very keen on state machines. I'm very keen on having it tell you what state it's in. I find it very much easier for me. So I've got the state up here. And you can see that I'm very keen on the language of state machines, and that it should be idling. And that tells you precisely what your system is doing or what the module is doing, because state machines can be sub-VIs as well. So here I know it's idling. Now if I press start, I know it's running. So it tends to lead your mind into the correct place. Now what do I have to do when it's running? And it tends to, what I'm trying to do is force my brain into thinking about the things that are happening at that one small moment in time. And it's a way of managing complexity, is rather than thinking about how the whole program's running or working, I'm only doing it in one small bit. So if I think that's all the ins and outs, all the technical aspects of the code. And you see it's not very big. Let's have a look. So if we get rid of the driver, the other thing it comes with is transparencies and things like that, splash screens and all the frivolities that you can have. If you take out the actual driver, there ain't a lot to it, which is nice. I've recently stripped it quite a long way back. And the other aspect of it is it's completely portable. So you can move this to any directory, chuck it on any machine, there's no dependencies. It'll just run, and that's another important thing. Let's see here, there ain't no dependencies apart from the VI-lib, which you can't get away with. But, I'm not a great fan of dependencies.
So Steve, do you use VI packages, or do you copy them to your VI-lib? Or so, like for example, James's tool.
James's tool completely copied to. So this is another rule I break that seems to infuriate people. I mean, I don't really care. I quite like infuriating people, but I like to see when shit changes in my project, and so I always have it directly mapped to the directly back to the file. So I'm always auto populating. But if we go into the there's James's stuff there. So every single project I make has that embedded in it. And I tend to do that with drivers and everything. So hardware drivers, if I can, I'll embed it in the source code. And all I then do is I park it up to one repository for the project. And the aim is that if I just gave my repository to anyone and they loaded the right version of LabVIEW, they could just download it off the repository and it work. And that's the aiming point. Now, obviously, with, I don't know, if you've got a key site scope, for example, that's next to impossible unless you want a 5 gig repository. But it's an aiming point. So that adding states is very much the same. Add a new state, update the enumerator type if you want a new transition. Again, I'm going to point you back to me whole thing about that. If you watch the GDevCon, unless anyone asks me specific questions, I won't bore you with going through the same thing again. But I like my state machines to have a transition, which is the important design aspect of this. So I like it to be in a state, waiting for a transition. That doesn't mean you can't bodge a state. I'm trying to find a bodge state. I haven't. So if you had a state that you wanted to poll, well, stick a while loop in it. I don't know, you know, but it should always transition out, and then you can map it to a state transition diagram. So that's the importance of that to me. The only annoying thing I find is that over time these just randomly expand. I'll try to fix that one, but a minor thing. Apart from that, that's well. So I was going to show you something a bit more complex now, because of the interesting way that Measurement and Automation Explorer deals with can't think of my words today. Deals with instruments that are imaginary. I may or may not be able to show this. Oh no, it's going to work today. Nice. Simulated, that's the word. There you go. What it does is it changes the name of them. It's very peculiar. Just bear with while I set this up. So this is a reasonably complex system that I've done. Also uses SQLite for its results, which is nice. Works very nicely. So I'm geeing up Tom. But really the point of this is just to show you that if I can set up my other system here. So this is a toe tank, and it should actually work. I've set this up wrong. So what it uses is it's project file is a SQLite file, depending on who logs in. That will log in a project file unique to them. So it gets you around a lot of security issues. So this is a university project. So being a university project, they want to be able to modify everything. You can see here, this is a state machine idling. And if we go into, I don't know, view the last run, you can see it's now viewing run data. So this is a big ass piece of software now. I'll just show you the code. You'll see it's following pretty much the same pattern as I showed you. It's bigger and bigger, assier, but it's still there. It's event loop, user interface queue, state machine, error handling. Certainly the same structure. It's just bigger. And the other aspect is if you want to do like a real-time system, I'm doing this on the fly, so if this doesn't work, I'll just switch the machine back on. There's a habit of changing its IP address. Beep. See if it works. Oh, it does work. Cool. Where is that? Wake up. Right. I just want to show you some code. So this is a real-time server when it finally boots up. As a headless real-time server, it doesn't need the event loop. It doesn't really need a user interface queue. But it does have inputs and outputs. And you should really think of the event loop as an input and the user interface queue as your output. So here, that's replaced with receive comms, which is UDP. So it's the same structure. It's just transmitting its watchdog. Yeah, so there's the display handling, and that's actually, it actually still is doing a bit of QE. Yeah, it's doing a bit of QE stuff because I want to be able to see the stuff, but the actual output is there, which is sending data. So that's queued up as well. And that's it really. So you see you can replace the structures quite easily. The actual lightweight feel of it is still the same, and that is a really massive program. That state machine is huge. I'll show you the diagram, shall I? And that's it. I think that's fulfilled my remit.
Steve, I had a question for yourself, if that's okay. Kabul, by the way.
Yeah, hi Kabul. How are you doing?
I'm good, thank you. With your example you were showing just now about having all of your dependencies, so drivers included, into your project, we are doing something similar at the moment. And what I had a question for you is, you don't seem to use anyway, well, you use auto-populating folders. So if someone has got those drivers installed in the computer, do you not get naming conflicts?
I suppose an example is FTP. So FTP is, if I load up my project manager, that's got FTP stuff in it. And I have to say, oh, I do a really brutal trick, is I just stick it in a library.
Yeah, I was
to
going to say.
protect the namespace. So for instrument drivers, I remove them from the instrument lib because I don't believe that they should just be sat around in your environment. So they get removed and moved. Now, if like for example, the National Instruments Modbus drivers, they don't design them to be portable. That is a real pain in the ass, but it's effort we put in. If it's nice, you know, it's just in one directory and you can move it around. That's people get a pat on the back for that. But yeah, we would remove that out of the system full stop, because that, to my mind, is you're just storing up a problem for your customer at some point. You know, because they're going to load it onto a machine, get it all set up, all these dependencies, and most of my customers don't. You know, their test equipment doesn't get access to downloading software, and it's probably not to be encouraged, in my opinion. So this is our project manager, and it's what we use for running all of our projects. So it does all of our project-y stuff. But if we dig down deep into the FTP, you can see all I've done is take the standard FTP library that you get with LabVIEW, and I actually had to hoik that out of the VI lib. And the reason why I wanted to hoik it out of VI lib is because the FTP library doesn't do one thing that's quite useful, which is tell me that, give me all I want is a slide bar telling me how much it's downloaded, and it doesn't do that. So essentially, yeah, I've just put a privately scoped global in there, which tells me the information I need.
Okay, so including the DLLs that it might be using, you copy them across as well?
Yes. Yes, if possible. That's the ideal. I mean, I say this is an ideal because, you know, for some instrument drivers, it's quite hard. So take the Keysight thing that I've got. It's got 2 gigs of download before you can get it going, and it's only Visa, and it really bugs me. But it has to have, you know, it has to have its own flavor of Visa. For God's sake, I just want to send it text with the Visa ports, and I'm sure I can, but so I'm looking at it thinking, how can I rewrite these drivers? Because I just don't want to haul around 2 gig of drivers with my code all the time, and I don't really want, you know, to deliver software and then my customer have to retrieve all the right drivers. It's just a faff that I don't like. So portability is very, very important to us. It's quite central to our design, the way we design our code. Everything should have relative paths, ideally, or a standard path. Does that answer your question?
Yeah, of course. I think one of the things that we stumbled upon, and we definitely have categories for this, so things like DQMH, for example. If it's a tool that's inbuilt to the environment, we kind of package that up into a VI PC as such, so that the environment does get set up, quick drop shortcuts, all of that kind of stuff. So we ended up effectively deciding that yes, there's a configuration to set up your environment as part of a LabVIEW install, but everything that the repository, your code project, needs, the majority of it, even things like, you know, what you pointed out with the TCP stuff, try and put it into the project is kind of what we're following as well. So yeah, definitely good.
Did you ever read my blog article about, I was whinging about reuse essentially, but it's to do with keeping code in the environment rather than against the project. That explains quite a lot of my thoughts on that. I'm just trying to find it. Oh, I'm not being, yeah, very, very long time ago. So yeah, this was me railing against keeping all the stuff here like you're supposed to, and that was one of my problems. I think BI Package Manager is an excellent tool, but the trouble is it's not solving the issue. It's become a very good workaround for the actual issue. Is that you shouldn't be modifying your environment for a project. I mean, where's the traceability of doing that? I just don't. I look at it and think, well, so I can take a VI in VI lib, modify it. Well, I've got source code control here, and that's not going to pick that up if I don't change the interface. So there's something that's modified. It's supposedly validated and under source code control, but it's been modified, and it will change if I put it on another machine. It just seems madness to me.
If you scroll to the kudos on that, did Petru end up giving you kudos for that?
Oh, I don't know. I've got 5 kudos for this. I've changed so much in the world of this.
That might be the reason why we've had many conversations around this.
No, Petru, he needs to. I think it's because I highlighted he was putting kudos on. Sorry, Petru. I stopped after I did that. I'm the worst enemy.
Yeah.
But,
can we all give Steve a kudos for that? I agree with most of the things. So let's make that 5 into 35. I think. I mean, one thing is, I mean, I don't know if you guys have used GPM at all. I mean, so GPM kind of sort of deals with this in a slightly different way. I mean, but at least it does install it onto your project than VI-lib or instrument lib. I mean, so that's one thing that, you know, I think I'm sort of gravitating towards. So.
I haven't looked at GPM yet, and I really ought. I think because I did ask Michael Viliotis is not part of this now, but I did ask. They said, "Oh, what can we do to make it do that?" And I said, "All I want you to do is give me a path that I can load my software to."
Mm-hmm.
But the trouble is that people have been writing these toolkits to live in here,
yes,
and they've not been making them movable. So if their toolkit has 2 directories, they put the directories side by side and not hierarchical, and then when you move them, they just get lost. And that kind of thing is very frustrating. Very frustrating.
So the one thing with the GPM is it's a very useful tool. Last I checked, it is an open source project, but it did not support localized repositories, so it was all in the global repository as such. Yeah, if anyone can get onto that, that would be super useful.
Oh, okay.
I mean, one thing I know that Derek Trepanier of MGI moved to Microsoft. I don't know if he still works with the LabVIEW community. I mean, so he's been really instrumental in getting this going. I mean, I don't know whether it stalls because of this reason. I'm a bit sad that he's moved on. I mean, I hope he still remains in the LabVIEW community. I mean, he was also involved in the MGI Solution Explorer as well, which now ships with 2020. So yeah, I hope somebody picks it up.
I think there's lots of semi-good ideas out there. I was hoping that G Central would pull them all together and give me everything that I want. But we'll see about that. It'd be nice if they do.
Yes.
Because that's the main thing. I mean, that's all I really want. And I know this is not everyone's use case, but I think it's nearly everyone's use case. Because as far as I'm concerned, I mean, I did a survey of CSlug, and nobody uses the user lib. Just nobody does. It's just like, well, if nobody uses it, and everyone's telling us we should be using it, there's something wrong. And I started exploring sort of dependencies, and I was just thinking, no, this is just how can you be nagging somebody to do source code control if a project doesn't define the project? It's never going to be under control. You know, it's just not. It's the machine that you load it on defines the project, but that's just wrong, isn't it?
It was one of the first things I hated about LabVIEW when I started using it. Having come from working on Linux C++ type projects, where basically within the repository was everything. You have 100 developers who you could guarantee 100% were using the same build environment, the same tool set, because it was all on a server and you connected. And when I started with LabVIEW, I thought, what is this? And and here we are 10 years later, and it's no better, really. Well, it's a little bit better.
I think you have to manage it yourself, and that's what we've done. You know, we put the hard miles, and it does reward you.
We took all drivers off the C code and put them in our repository. Telnet, any driver, it wasn't allowed to live in instruments. It had to be copied into our repository because we often had to change them.
But if you validate your code, it has to be validated against a build. And that's, if that build can be changed by the environment, you can't validate. You know, and that's the other thing is you know, if you work in FDA sort of approved stuff, or even flying aerospace, that's just I just don't know how you would validate a project. But there you go.
So one of the things we've done is actually taking it to the next level and taking VI-lib and taking what we call a golden copy of that and stuff that up into our repository. And then every time we install a new LabVIEW on a new development system, we force a golden copy of VI-lib from our repository back down onto the system. And whenever anyone mucks something up in VI-lib, we just say export from the repository again, start over, have a clean install, and then we have traceability to exactly what we consider VI-lib.
Oh, that's interesting. I mean, this my blog article rattled on for about 4 more articles, and the solution, I think the people actually on the next gen side thought about it. The thing I wanted was, okay, if you're going to leave something open source in VI-lib, if you can modify a VI-lib, then the way LabVIEW should handle that is say, yeah, well, you're not going to store that back in VI-lib. That's read only. You just put it. You would name that as a, you know, VI-lib modified. Stick it in your project. And I thought that's the only change really they needed to make, is that if anyone modified anything from the, you know, you just couldn't modify anything in VI-lib, like exactly what you've done there is enforced. That's quite clever. I didn't think about doing that.
Yeah, but that if you could put a build flag in to disable a build if VI-lib is changed.
Yeah.
So as you say, you make it read only, it's unlocked if you want to, but a build flag stops it being built and stops the release build being built or something like that.
Yeah. Or you build it on a different machine altogether. I mean,
that's the other thing.
Which is advised.
Yeah.
I don't.
Yeah.
I'm lazy. Right. I'm cheap.
Yeah. Thank you, Steve. That was really wonderful. Any more questions for what Steve would present? I mean, there's one thing that's probably not talked about, and it's in the GDevCon presentation that Steve gave, was the difference between transition and states, and why the LabVIEW state machine template is not an actual state machine, and why states and transitions are important. So, and it's really interesting. I mean, I'd really recommend, if anybody hasn't seen it, I mean, should go and have a look at it. And if you're interested in state machines, there's also another NI Week presentation by Norman Kirchner about state machines as well. I think he did it 3 years ago. That was pretty cool as well, and eye-opening to me. So yeah, really good resources. I mean, and thanks very much. Any more questions? All right, thank you, Steve. Shall we all do an applause?
Ah, here we go.
Cheers, Steve.
No worries at all.